Welcome to the National University online class, subject mathematics, course code 213703, name of the course, Advanced Calculus 1. Title of the lecture, Properties of Definite Integral. This is Muhammad Zakir Hussain, Assistant Professor, Government Tularam College. Dear students, this is lecture number 11. Today we would like to discuss about properties of definite integral. There are a number of properties of definite integral. It's very effective to solve these types of problem regarding the definite integral. There are different types of definite integral. Some problems are related to um, this pattern. That's you have to know the properties of definite integral to solve this that types of problem. So let's start. Enjoy the class. Number one. Say problem number one. Proof that integration a to b f of x dx equal to minus integrations limit change b to a f of x dx. Okay, when a limit change, that is change means lower upper, if lower upper change each other, that times the integration will be negative. This is our problem. Okay, let's start. Proof. Let antiderivatives f of x, that is a prime of x equal to f of x. For the antiderivatives of f of x, a prime of the a prime of x equal to f of x. If you differentiate it or integrate it, as we know, the differentiation and integration are that is inverse process. So alter, that is f prime of is a first derivative. If you integrate first derivative, it will be f of x. So that's why f of x dx, we can take it in this way after using integrations. That is integrations f of x dx equal to f of x. Okay, both sides. If we integrate both sides with the both at that times, it will be integration f of x dx equal to, look, my dear student, this is f of x. So if you integrate here with respect to x, that is integrations, here is integration, so it will be integration f of x dx equal to f of x, because this is first derivative of x. So it will be after integrations, it will be only f of x. Okay, now integrations a to b f of x dx equal to, as from the antiderivatives, we know it will be f of x. So limit a to b. So if we substitute the value, it will be, first we have to substitute the upper value, then the lower value. Method, you know, from the rules. So it will be f of b minus f of a. This is number equation. So one. Look, you know, f of x a to b. So how do you there is substitute the value? Already I told this is f of b minus f of a. Number one. And minus integrations b to a f of x dx equal to what? It will be minus f of x b to a, that is the upper value here a. So minus f of a minus second bracket, then this minus for this minus, nothing else. So you have to put the value of a here first. So f of a minus f of b, because b are the lower value. So f of a minus f of b. Okay, after simplifying, minus f of a plus f of b. So f of b is minus f of a. This is number two. So from 1 and 2 are similar each other. So that's why from 1 and 2 we get this is our statement. This is we have to prove this one. So integrations a to b f of x is equal to minus integrates b to a f of x dx is proved. Okay, so my dear students, this is our uh, this is the way to prove these types of problem. Okay, so you have to understand what's the way to prove these types of properties. This is sometimes you have to face different types of different integral where you have to use these properties. Okay, so Del Gourmet is the properties of definite integral. Okay. Number two, prove that this one here integrations a to b f of x dx equal to a to b in f of z dz. Okay. Prove let f of integration f of x dx equal to f of b from the previous problem. So properties we know already. Integrations is for a derivatives integration f of x dx equal to f of x already we know, and that's why this is the variable is x. Now we can take z, so for z it will be integration f of z dz equal to f of z. Okay, my dear students, sometimes you have to use previous logic or previous any techniques, previous any formula, uh, because mathematics is totally depends on the logic. Okay, logic means formula. If you was not serious to recall your previous properties formula, so you will not be able to solve or you will not be able to prove any types of problem. So, okay, so sometimes you have to know that from the previous problem, there is the proof. Uh, for alleged antiderivatives, so integration f of z, they are actually f of, say if I get previous, look, antiderivatives f of x, that is first derivative of x equal to f of x. If we integrate both sides with respect to x, it will be integration f of x dx equal to f of x, capital F of x. So this is very effective. Okay, that's you have to remember. Okay, now go to the left side. That is the this is the problem two. Okay, so from the previous problem, that is integration f of x dx equal to f of x. So for z, integration f of z dz equal to f of z. Okay, and now integration a to b f of x dx equal to after after integration it will be f of x and the limit will be a to B. Okay, the how to substitute the lower upper value in your functions. It will be f of b minus f of b. And integration a to b f of z dz. The same parameter you have to follow. That is the f of z whole to the power, and that is the power a to b. Okay, substitute the value f of b minus f of a. This is the there is the previous knowledge, previous logic, how to substitute the limit. Okay, so these two values are each other equal. That's why we can check integration a to b f of x dx equal to integration a to b f of z dz. It's very easy, but this is the properties that you have to remember. Sometimes these types of logic will be recalled to solve these different types of different integrals. My dear students, be sincere. Here, this is easy. Okay, but I know in my previous experience, most of the students don't like to that is remember, don't like to know about the properties of different integral. If you want to know the techniques, the logic, the properties, if you want to express the Kepler's one frequently, that is, if you want to teach anybody, you need some logic, techniques, properties, formula. Okay, you have to be sharp about this one. Okay, uh, so proved already. Problem two. Our next problem is prove that integration a to b f of x dx equal to a to c f of x dx plus c to b f of x dx when a less than c less than b. Okay, less than c. This is c, not e. This is c. Okay, take it c because this is our problem. Okay, proof. Like we know integration f of x dx equal to f of x. Okay, so integration a to b f of x dx equal to f of x. The same process we're going on. A to b, substitute the upper value minus the lower value. This is number one. And a to c f of x dx plus c to d f of x equal to f of x. After the integration, say the limit a to c here, limit c to b. Okay, substitute these two values. That is f of c, the upper for c. That's why f of c minus lower a. So f of a plus the upper is b. So f of b minus lower is c. So minus f of c. Okay, cut the equal values. So minus f of c plus f of c will be deleted. So finally we found f of b minus f of a. This is number two. Okay, so from 1 and 2 we get integration a to b f of x dx equal to integrations a to c f of x dx plus integration c to b f of x dx. My dear students, it's very easy. Okay, but you have to sincere. Say these two things. Well, it is our techniques. These C and upper C and the lower C equal. So CC will be cancelled. The rest limit will be A to B. This is the logic. Okay, this is the logic because these types of logic are used in different types of important sum. Okay, if you're not able to you say you don't know this logic, so when you face say like these types of related definite integral, how do you solve? Okay, you have to know the logic first, then you can proceed. Okay, so number three problem, number four, prove that zero integrations 0 to a f of x dx equal to integration 0 to a f of a minus x. My dear students, let I'm taking the right side. Integrations 0 to a f of a minus x dx. Let a minus x equal to z. Therefore, after differentiating with respect to x, it will be dx minus dz. Okay, so here zero here say when it is it's for a zero, and when zero it is a. It is f of now f for a minus x for z and dx for minus dz. Okay, you're taking the negative sign in the left side. Now if we drop the negative sign from here, the limit will be changed. Lower upper will be changed. Okay, so here is lower a, it will be upper, and the upper is zero, it will be lower. So integration 0 to a f of z dz. Okay, finally, if you change, you take x instead of z, it will be a to 0 to a f of x dx. So this is the left side. So my dear students, this is the properties, very effective properties. There are a number of sum in this exercise. This is that types of sum is sums are directly related to this properties. So you have to know the properties, very effective properties. Okay. Now we are taking number 5. Say the next problem is number 5. Prove that integration 0 to twice a f of x dx equal to 2 integration 0 to a f of x dx. Okay, when integrations twice a minus x equal to f of x. Prove that this is a proof. We know 0 to twice a of x dx equal to 0 to a of x dx, and from the previous properties that we proved already, 0 to a f of x dx plus a to twice a f of x dx as dx. This is number one. In second integral from the right hand side, right? So here, yeah, right hand side here, twice a minus x. So we considering this is x for twice a minus z. So after differentiating with respect to x, it will be so dx equal to minus dz. Okay, and then the change the limit when x equal to a, it is say a, and x equal to a, it will be z is equal to what? Z is equal to a when x equal to twice a and z equal to 0. Okay, change the limit 0 to twice a, 0 to twice a. Now, f of x dx equal to 0 to a f of x dx plus a to 0. Okay, uh, integrations twice a minus z here minus dz. ঠিক আছে, এটা কিন্তু আমরা ভ্যালুগুলো বসানোর পরে আমরা এটা পেলাম। ওকে, তুমি যদি ভ্যালুটা বসিয়ে দাও, ঠিক আছে, তাহলে তুমি এই কনসেপ্টটা পেয়ে যাবে। এই কনসেপ্টটা তুমি যে পেয়ে যাবে, দেখো এখানে এই যে এখানে ছিল নাম্বার ওয়ান, এই নাম্বার ওয়ানে কিন্তু তুমি ভ্যালু বসাচ্ছ, আর অন্য কোথাও ভ্যালু বসাবে না। এই যে a to 0 এটা পেয়ে গেছো, প্লাস এখানে এই twice a for 0 আর a for a, এখানে কিন্তু এটা লেখা হয়েছে। আবার f of x এটা পরিবর্তিত করে f of x মানে twice a minus x। সো তুমি এখানে এটার পরিবর্তে লিখতে পারো twice a minus z। ওকে, বিকজ আচ্ছা আমরা এটা x ধরে নিয়েছি, আবার এটা লিখবা minus dz। সো দিস ইজ দ্য techniques. Now integration 0 to a f of x dx plus integrations 0 to a f of twice a minus dz minus, if you change the minus, you know, the limit will be changed, each other lower and upper will be changed. Okay, so on the upper value right now a and the lower is 0. Okay, now 0 to a f of x dx plus 0 to a here twice a change, because as we know integration a to b f of x dx equal to integration a to b f of z dz, as we know, so from the logic, so it will be twice a minus x dx. Okay, now 0 to a f of x dx plus integration 0 to a f of x, because we know f of twice a minus x equal to f of x. So here twice a minus x, that's why you can take x, so f of x dx. Now therefore 0 to twice a f of x dx equal to 2. Thus this is the similar. So this the left part and the right part same, so it is twice integration 0 to a f of x dx. So here look, so that's why we can prove this one. And now this is proof, my dear students. Look, this to this equal to this already we proved. So this is the way to prove these types of properties. Okay, note if functions twice a minus x equal to minus f of x, then 0 to twice a f of x dx, it will be integration 0 to a f of x dx minus 0 to a f of x dx equal to 0. মনে রাখবে, যখন এটা নেগেটিভ হবে তখন এই পার্টটা কি হবে, 0 হবে। এটা জাস্ট মনে রাখতে হবে। Okay, this is our next problem. Prove that 0 to n a f of x dx equal to n, as we proved already. 0 to twice a f of x dx equal to 2 into integration 0 to f of dx. So the similar problem, similar properties. So n 0 to a f of x dx if f of x plus a equal to f of x. Proof. We know that this 0 to n f of x dx equal to আমরা এইভাবে লিখতে পারি 0 to a f of x dx plus a, so this is a plus twice a f of x dx. Now twice a, so lower will be twice a, thrice upper thrice a f of x dx, and dot 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 plus we can check this is n minus n a, so it will be 1 down, so n minus 1 a f of x dx. This is the series. We can present it in this way. Okay, so we are taking this is I1, I2, I3, and dot dot In. Okay, this is number 1. Okay, let here this is our problem f of x plus a. So that's why x equal to a plus z we can take. Okay, so this will be z is equal to a plus x. Okay, my students, check in this way. This is z and this is x. Not like that. It's a mistake. Here you can take z. Let z is equal to a plus x because here x plus x. Differentiation with respect to x, it will be dx is equal to dz. Now x equal to a. When x equal to a, z is equal to what? Another way you can think in this way, say as we know f of x plus a is equal to from the previous properties, we can think in this way, f of z plus a equal to integrations z, there is the functions f of x plus a equal to f of x. That's why we can take in this way functions z plus a equal to f of z, f of z. So here in that term we can take it x equal to a plus z and this, and so when x equal to a, in this case it will be a plus z. There what I told, okay, and check it, it's explained only here. It is equal to 0 to twice a f of x dx, so 0 to a it is a plus z dz. So here a plus z, we are taking this one x is x equal to a plus z. Okay, so x equal to a, then z is equal to 0. Okay, again when x equal to twice a, then z is equal to a. Sometimes that is we have to think a different way. First, when from without doing this one, if any students think x equal to x plus a, so it will be z, so it is wrong. So for this reason I told before it was wrong. Actually when you think in this way, there is, after proceeding this one, it's correct. So where is wrong, where is correct, you have to understand. These two things are presented. Okay, আমি প্রথমেই বলেছি যে এটা রং, তারপরে পরে বলছি যদি আমরা এটা আছে রাইট। সো রং এবং রাইটটা এটা ভালোভাবে ডিফাইন করবে। ওকে, সো এটা কিন্তু রং নয়। এই প্রসিড করার পরে আমরা এইভাবে করবো, বিকজ আমরা প্রপার্টিস যে প্রুভ করার জন্য আমাদেরকে জেডে আনতে হবে। হ্যাঁ, কিছু যদি একেবারে সরাসরি প্রিভিয়াস যা রেকর্ডেড আছে সেখান থেকে যদি আমরা ধরি, তাহলে কিন্তু আমাদের রং মনে হবে। আসলে কিন্তু এটা রং নয়। তোমরা এটাকে কি করে নেবে, x প্লাস a আছে, ওখানে z প্লাস a ধরবে, বিকজ আমরা প্রিভিয়াস প্রপার্টিস থেকে আমরা অলরেডি জানি। ওকে, তাহলে তো তোমার আর এখান থেকে কোনো দ্যাট ইজ কোনো ট্রাবল থাকবে না, বুঝতে কোনো অসুবিধা হবে না। ওকে, সো ইন ডিটেলস আগে কথা শুনবে, ভালো করে বুঝবে কখন রং কখন রাইট। ঠিক আছে, আবার দুটো যদি গুলিয়ে ফেলো তাহলে ইট উইল বি ডিফিকাল্ট টু আন্ডারস্ট্যান্ড। ওকে ওকে, in the next slide it is 0 to a. It is 0 to a. So f, that is f of a plus x dx equal to 0 to f of x dx, as we know this one. Okay, this is I1. Similarly, prove that I3 is equal to I4 and dot dot is equal to In equal to I. So from from the similarities, this is the way to prove this one. Finally, we found from number 1, 0 to na, integration 0 to na of x dx equal to I1. Okay, I1 dot dot. So it will be n I1. So you can write down finally 0 to na, integration 0 to na f of x dx equal to n into I for integration 0 to a f of x dx. My students, this is the way to prove these types of problem. Okay. Number 7, prove that minus integration minus a to a f of x dx equal to 0 to a f of x plus f of minus x dx. This is the different types of properties. Okay, and show that this is equal to this. We have to prove this one. Prove. We know that integration minus a to a f of x dx equal to minus a to 0 f of x dx plus integration 0 to a f of x dx. We know it because we did it already. Okay, so therefore minus a to f of x dx equal to 0 to f of x dx, minus a to minus a to 0 f of x dx. This is number 1. Okay, we are taking it. This is number 1. From the right hand second integral, let x equal to minus z. We are taking x equal to minus z, so that's why a differentiation with respect to x, it will be dx equal to minus dz. When x equal to 0, z equal to 0. When x equal to minus a, z equal to a. Okay, now this is the x form. Now the 0 to f of x dx minus a to 0 f of minus dz minus x dz equal to 0 to f of x dx plus if we drop the negative sign, the limit will be changed. So now 0 to a and this is f of minus dz minus z and dz. So here 0 to f of x dx here, this one 0 to a f of say minus x dx, as you know, this is equal to this. Already we did it. Okay, this is the z is x equal to z. We can take it. So from the properties we are taking it. Now this is 0 to a f of x plus f of minus x dx. We can take in this way. So second part, if f of x is even functions, then f of x equal to minus f of x, and that is integration minus a to a f of x dx equal to 2 0 to a f of x dx. Okay. For even functions, if even functions, this will be 2 into integration 0 to a f of x dx. For odd functions, when it is odd, f of x is odd function, that times f of x equal to minus f of x for odd. Okay, so that is this is equal to for odd functions negative, so it will be 0. So that it is 0. So for even function, it is 2 into 0 to f of x dx. When this is the even functions, and when the odd functions, it is 0. So it is proved. So this is the where the technique, is the logical way to prove these types of properties. Okay, my dear students, try to understand now. Say problem 8. Okay. Determine 0 to pi by 2 cos x divided by sin x plus cos x dx. My dear students, uh, here dx should be omitted. This dx omitted or this dx omitted. Take it easy. Okay. Let I for the problem number one. As we know, from the properties number four that we already proved, from the properties number four, we can take in this way 0 to pi by 2 cos pi by 2 minus x, here sine pi by 2 minus x, and cos pi by 2 minus x ds. Because we know this it was from the properties number four. If you back number 4, then you can see this one. Okay, now this is changed, so it will be sin x. This is sin x, and this is cos x. This cos x and this sin x. The first quadrant all positives. Okay, this is the dx. Number 2. So twice a, we are taking uh, this one twice high. Cos x plus sin x, 1 and 1. This is number, say, this is 1 and this is 2. If we add this number 1 and number 2, finally, uh, we found twice I equal to, this is not 2, 1 plus 2, এক number and 2 number সমীকরণকে আমরা যোগ করেছি. Okay, so twice I is equal to this. So upper and lower, denominator numerator same, so it is this upper and lower same, so it will be vanished, it will be deleted, it will be omitted, whatever it is. Okay, now dx. So as you know, so it will be x, the upper pi by 2 and lower 0. So substituting the limit, it will be pi by 2 minus 0. So I for pi by 4, because here is 2. If we take the right side, it will be pi by 4. Okay. Now, problem number 9. Determine 0 to pi by 4 ln 1 plus tan theta d theta. So it is let I for this now 0 to pi by 4 ln 1 plus tan pi by 4 according to the properties number 4. Now this one ln 1 plus this is a tan a minus b. You have to apply tan a minus b. So tan a minus tan b divided by 1 plus tan a tan b. Tan pi by 4, that is 1. So 1 minus tan theta divided by 1 plus tan theta d theta. Okay. Now, 0 to pi by 4 ln, after LCM, it will be 2 divided by 1 plus tan theta. Because এখানে লসাগু করে, that is doing LCM. 1 plus tan theta plus 1 minus tan theta. So plus tan theta minus tan theta cut, and the rest will be 2. So therefore this is 2 divided by 1 plus tan theta d theta. As we know, ln m by n equal to ln m minus ln n. So this formula is being used here. So ln 2 minus ln 1 plus tan theta d theta. Okay. Now ln theta ln 2 theta pi by 4. This is the problem. So we are taking it integration 0 to pi by 4. This for I. Okay, this for I, and this is ln 2. Ln 2, if we integrate this one, ln is the coefficient, takes we're taking the outside of the integrations. So ln 2 now theta to the power 0 to pi by 4. So if you substitute these two values, so it will be a ln pi by 4, and the right side minus I. If we take in the left side, it will be twice I equal to ln 2 pi by 4. That's why finally we found I equal to pi by 8 into ln 2. This is our last problem. Okay. Finally the result is I equal to pi by 8 ln 2. Okay. So my dear students, this is our report result. Okay. If we discuss the whole things, if we talk about the whole things briefly, there is that is uh, that is the properties of definite integral. There are different types of properties. You have to know the properties perfectly to use different types of definite integral. Okay, if you want to solve number of there's the integrations, definite integral. There are a lot of problems. How do you understand? You can't solve different types of definition in the same way. Sometimes you have to use the properties. So here we are discussed already uh, these types of problem. That is, if you would like to solve these types of problem, you have to know the properties, because according to the properties we have to solve these types of problem. Okay, thank you, hope for the best. um, Thanks for watching the class.